Welcome to mathworksheet.org. Today what I want to show you how to do is solve a problem using right triangle trigonometry. So what we're going to be talking about here is when we're given a right triangle, how can we solve for a missing value? A couple things I want to remind you of is when we have a right triangle, how can we label it? Well, first of all, we know that a right triangle is going to be a right triangle by one of its angles is going to be 90 degrees. And we'll usually label that with a little box. Now, of a right triangle, off of that 90-degree angle are the two legs of the triangle. One is what we call adjacent, and one is what we're going to call the opposite side. I'll get to why we call those in just a second. The side length that's directly across from your 90-degree angle, a lot of times we say that the 90-degree angle points towards it, is what we call our hypotenuse. Now, if we have an angle out besides our 90-degree angle, we call that angle usually theta. And theta is going to help us determine which side lengths, which of our legs are our adjacent and our opposite side. So the opposite side is the side that is opposite of your angle theta. Your adjacent side is going to be the side length that connects your angle theta and your right angle. Now, when using right triangle trigonometry, we have some functions that we can use to solve for our missing side lengths. And that's what we have our sine, cosine, and tangent. Now, these are all functions that are going to use the ratios of our side lengths that are given our triangle. So right here we have a problem where I have a right triangle. My angle has been given, which is 15 degrees. My hypotenuse is 10. And my side length, which I know is going to be at my adjacent side, is going to be x. So what I'm going to want to use is I'm going to want to use these functions to solve for my missing angle x. Now, I look at these three functions and I need to determine which is going to be the best function to choose. Well, I know that sine represents my opposite over my hypotenuse. So I know my opposite on my hypotenuse. In this problem, I am not given the opposite side, so it would not be useful for me to use sine. Tangent, I'm also going to use the opposite side, so it will not be useful to use tangent. However, for using the cosine, I'm only going to have to know the adjacent and the hypotenuse. So what I can do is I'm going to use my adjacent, my hypotenuse, and my angle theta to plug it into my cosine function. So I'll write cosine, rather of theta, I know my angle theta is 15 degrees, equals the ratio of my adjacent side over my hypotenuse. So my adjacent side of this triangle is going to be x over 10. Now, it will be very helpful to have a scientific calculator so you can evaluate what cosine of 15 degrees is. Cosine of 15 degrees is going to be, when you round it, will be 0.97 equals x times 10. So now, to find my value of x, what I need to do is get the x by itself, meaning isolate it. So right now I have my variable being divided by 10. So to get rid of dividing by 10, I simply need to multiply the left and right side by 10. So there, by multiplying by 10, I'm going to move my decimal one more over. So I'll have 9.7 equals x. So looking at my triangle, I have now just determined what the adjacent side of my angle is. Or I'm sorry, adjacent side of my triangle, which is 9.7. So that's how you solve this missing triangle. Thank you.